All right, here we go. We have started. All right, so we are going to finish up. That's why I put B next to it, 5.5B. Now, your homework's not going to have a B next to it because I haven't assigned the homework yet. All right, so it'll just be 5.5. But on this lesson, I'll call it B since it's the second part of it. All right, let me move a couple things over here. All right, we're going to start right with an example, and then I'm going to teach us something a little bit new. So this is an example of the last thing that we talked about. This is example 4. And it says compare the given measures, all right? That's what this stuff, this inequality stuff, that's what you're going to do here. You're going to compare. So it says compare the given measures. And they'll tell you what the measures are here in a second. But let me just write this down. All right, so here's A. And let's draw the picture first. Looks like, it looks like it's a trapezoid. Have we talked trapezoids in here yet? No? Okay, forget what I said. It is a trapezoid, but we haven't really talked about it. In the next chapter, we're going to talk about it because in the other class, we've been doing trapezoids. But anyway, don't worry about what a trapezoid is just yet. Don't worry. It'll be fine. All right, so I got this thing right there. By the way, you got your note? Anybody got their notes out? What was the last theorem that we did? Didn't we did you write down the actual theorem? The greater angle theorem? What about the one before that?
So when A plus B equals C, it is a right triangle.
Oh, you know what? No wonder. Don't write this example. I got my notes in the wrong order. I got my second page in front of my first page. Well, wait a minute. Let me see. No, I might be right. Oh, yeah, I got to do that. I'm sorry. Yeah, I put this a little too early. Let me just scooch down. Sorry about that. Yeah, we'll eventually do that one. But let's talk about this theorem right here. I am not going to write the whole thing down because it's super long, but I will write the name. They give it a special name. So you figure when they give you a special name for these theorems, it's probably pretty important, and this one is. But I'll draw a picture, and we'll describe it through the picture. I think it's a little easier for you than me writing the whole thing down. It's called the hinge theorem. Okay, a hinge, like on a door, right? You open a door, it's on a hinge, right? Goes back and forth like this, okay? That's what they're talking about as a hinge. All right, let me draw a couple pictures, and I'll read the theorem, and then we'll see what we got here. All right, so I've got this one, and I've got this one right here, like that. Okay, so what kind of triangle is that? Acute? Looks obtuse to me. Well, I kind of didn't hit it right there, but that's okay. You get the idea. Yeah, I think it's fine. Now, what I'm going to do is this. Now, watch very carefully. Before I even talk about the theorem, let me show you. See this bottom length right here? We're going to call that, I'll tell you what, let's write it down first. We'll say the length of that one is 8 and the length of this one is 5. Everybody with me? And what we're going to do is we're going to compare the third side of one triangle to the third side of another triangle. So right now, we have not compared two different triangles to each other. We've only compared like sides in one triangle and angles in one triangle. But now we're comparing two triangles to each other. So watch what I'm going to do. I'm going to copy and paste that bottom one. So how long is that one right there that I just pasted? It's 8. Everybody see that? I copied and pasted it, so that's exactly 8. So that one and that one's the same. But watch what I'm going to do here. I'm going to take this side. I'm going to copy and paste that. So what's the length of this side right here? That's a 5. All right, and I'm going to rotate it. I think I can hit R for rotate. Yep. So now look, I'm not changing the length of it, did I? Just rotated it. So the length of this is still 5. I just rotated it a little bit, just changed the angle. So that's an 8 and that's a 5. That's an 8 and that's a 5. So if I connect the third side right here, here's what the hinge theorem tells us. You started off with two equal sides. Would you agree? So this side and this side were equal. This side and this side were equal. Now, is that enough to say that they're congruent triangles? No, it's not. Just two sides is not enough. All right, I'd have to know the third side. Well, I don't know the third side, but watch this. If I have two sides and one angle, I'll do this in a different color right here. And if one angle in between is bigger than the other angle in the other triangle. Everybody see me? So I've got two sides that are equal, but the angle in between, even though that's got one arc and that's got one arc, this one's bigger, isn't it? Tell you what, let's put two arcs there, okay? So this arc, this angle right here is bigger than this angle right here. So it's almost like side angle side, isn't it? Except what's the problem though? The two sides are equal, but the what? The angles are not equal, are they? Okay, but look at this. This angle is bigger than this angle. So if you look at the third side now, what do you think might be true about this side compared to this side right here? We'll call this, I don't know, we'll just call this side A and side B, okay? The one on the left. So which one on the left? It's A, side A, right. So side A is going to be bigger than side B. You follow me on that? So if you have, and this book calls it the hinge theorem. I've seen it before. It's not like they're the only book that calls it that. But I've seen other books call it this, the side angle side inequality theorem. I kind of like that because it kind of describes it a little bit better. The two sides are equal. Everybody see that? But the angle between those two sides are different. So if this angle that's between the two equal sides is bigger, then the side opposite the bigger angle is going to be bigger than the side opposite the what? The smaller angle. So I could say this. I could say side A would be what? What's my inequality thing? Is greater than what? Side B. Does that make sense? And why is it? Because this side A is opposite the bigger angle than side B is. So side A is opposite the big angle. Side B is opposite the smaller angle. So that means side A must be bigger than side B. You got it? It's in the book. Anybody got their book open? Who's got their book open? What page is the hinge theorem on? It's on section 5.5, but it's probably like in the middle of the lesson. Hinge theorem, it should say. What page is that on? Anybody? Section 5.5. It's probably second or third page, maybe. I don't know. It's 235. Okay, 235. So let's look at it. It says this. I'm going to read it. I'm not going to write it down because it's too much to write. Here's what it says, though. It says if two angles of one triangle, I'm sorry, I read it wrong. Can't even read my own handwriting. If two sides of one triangle are congruent to two sides of another triangle, do we have that situation here? Do I have two sides of one triangle equaling two sides of another triangle? I absolutely do. And the included angle of the first triangle, which one is the included angle of the first triangle? It's this one right here. Okay? If that included angle is larger than the included angle of the second triangle, you with me? So if the included angle of this one is larger than the included angle of this one, then the third side of the first triangle is what? Larger than the third side of the second triangle. You follow me? Okay, it's a lot of words. If I said it really fast, you probably think, what in the world is he saying? Okay, but if I have two sides of one triangle equal two sides of the other, the included angle of the first triangle is bigger than the included angle of the second triangle, then the side opposite, the bigger one, okay, is larger, greater than the side opposite, the smaller one. That's basically what it's saying. We good with that? We kind of had that earlier. Do you remember what we did earlier? Let me just remind you. Let's say we had a triangle that looks like this. And I said that this was, 2, this was 4, and this was 5. Okay? Let's put ABC. So this is just one triangle, isn't it? Okay, this is one triangle. But I'm comparing. I'm making a comparison. I've got 2, 4, and 5. On this one, I should be able to tell which one is the biggest side, or the biggest angle. Which one is the biggest angle on this yellow triangle? Give me a letter. Angle A. How do you know angle A is the biggest angle? Just because it looks like it? Because it's opposite the biggest side. Do you see it? So this is the biggest angle. What's the smallest angle in this yellow triangle? Angle B. All right, so we'll make it 3 right there. And then what's the middle one? It'd be C. Okay, so this is kind of like this, isn't it? Except it's a little different because we're not just talking about one triangle. We're comparing what? 2 different triangles, okay? Everybody got it? So it's the same idea because the side opposite the bigger angle is greater than the side opposite the smaller angle of the other triangle. But this one I'm comparing 2 triangles. This one I'm just comparing the sides, right, of the one triangle. Do you see the difference? Okay. Here's another one. It's kind of the same thing. Tell you what, I'm just, so I don't have to draw these, I'm going to copy this, and I'll get rid of a couple things here. Let's say, let's get rid of that. Let's get rid of that. Let's get rid of this. Let's get rid of this. All right. Let's say we already start off with the 2 equal sides. This is 8, 5. This is 8 and 5. So 2 sides of this are equal to 2 sides of this. But what if I told you that this side right here was bigger? What if I told you that this side right here was bigger? And I'm going to put, watch. I'm going to put a big old tick mark right there, okay? It's bigger than this side right here. So this is the converse of the hinge theorem. So it starts off the same way, 2 sides equal to 2 sides. But this time I tell you that this side right here, the third side, is bigger than this third side. What do you think that tells you? I'll tell you what, just to make it easy. D, E, F. All right, what do you think that tells you about something else in here? So they tell you that AB is bigger than, what's that, E? I can't even read my writing. DE? Everybody see that? What do you think that tells you about something else in the triangle? Angle F is what? Smaller than angle C, exactly. Or you could say what? Angle C is bigger or greater than angle F. Everybody got that? That's the converse. So the first one, the actual hinge theorem, it said that this angle was bigger than this one, so you could say something about the sides. This one, they tell you the sides, one side is bigger than the other, and that means that the angle opposite has got to be bigger. Make sense? Same kind of thing, they just tell you different information. So that's why they call it the converse of the hinge theorem, all right? So instead of saying this angle is bigger than this one, they say this side is bigger than this one, and then that means that C is greater than F, okay? Now we can actually do that example that I was about to do when we first got on here. So do you have that picture already drawn? I guess I could just copy it, couldn't I? Let's copy all of this. And let's get rid of that. Copy that. Let's go back to this. Okay, here we go. That was quick. Here's some, they give you some stuff. They give you some information. All right. We haven't used this pink color very much. Let's use that. Yes. Well, I thought I was using pink. That's okay. Let's name the points. They even give you some numbers. They say that's 7. They say that's 5. And they tell you that this side is equal to this side. And they tell you, well, they don't even have to tell you that, do they? You know that that in this triangle is equal to that one in that triangle. All right. So what are they trying to do here? It says compare the given measures. Well, they haven't given you any measures yet, so let's put some stuff down. So here's the question they could ask you on the homework. Obviously, if it's on the homework, it could be where else? On the quiz or a test. All right, so KNL. So angle KNL, and I'm going to put a blank right there. So what do we put in the blank? We put less than, greater than, or equal, okay? So we're comparing that angle to this angle, MLN. All right. So let's do this first before I do anything else. John, go ahead. Let's do this. Let's mark these two angles so I know which ones we're talking about. KNL. Where is KNL? Well, there's K, there's N, and there's L. So I'm comparing this one to what? MLN. MLN, that would be this one right up here. I don't know if they're equal to each other, so I'll put two different ones right there. Everybody with me? So I want to see, is this one down here on the bottom, is that greater than this one? Is it less than? Is it equal? Well, let's take a look. Do we have that side angle side inequality thing going on here? Well, I got a side and a side, don't I? You see that? And I got that same side over here and that same side right there. I got an angle in between. We call it the included angle. All right, so I got the angle in between, but I don't know which one is bigger or which one is smaller. I don't know. I can't just look at it and say, well, that looks bigger, that looks smaller than this one. Sometimes you just don't know. You just can't go by what the picture says. You've got to go by the information. So where do we look? If I want to compare this angle to this angle, where do I look? I look at the side that's what to it? No, not perpendicular. We never said. What is it? Yeah, but we want to look at the side that's opposite. It's opposite, okay? Everybody see it? There's my side, there's my angle, and there's my side. So I take that angle and I look to the side that's opposite that angle. So what is the length of the side that's opposite this angle right here? It's 5, isn't it? Okay? So this one arc is opposite 5. What about this angle right here? What's opposite this angle right here? A 7. So, yeah, what is KNL, this one down here? It's opposite the 5 compared to this one, which is opposite the 7. So this one's got to be what? Less than this one right here. See how easy that is? Everybody see it? All right, as long as you got the two equal sides, now you can compare the angles if you know the opposite side, right? And they gave it to you. I mean, it's pretty easy. All right, and obviously you know 7 is bigger than 5 or 5 is smaller than 7. So this is opposite the 5. It's opposite the smaller side, right? Because this one's opposite the 7. So this is opposite the smaller side. It's a smaller angle. This one's opposite the bigger side, so it's the bigger angle. It doesn't tell me how many degrees it is, but it does at least tell me that this one is smaller than this one. And that's what they're asking for, okay? It's right there. What do you think? Let's do another one. We got 2 more examples. Yep, 2 more examples, and then we'll be finished. So let me draw this. So you draw it along with me. Don't just sit there and watch me draw this thing. Okay. And I got one more. Let's connect from here to here. You should be looking up here and drawing this. It shouldn't be any talking. So I've got V, that's a U, it's a W, and this is an X. All right? And they tell you a few things, so let's write down what they tell you. They tell you that this side is equal, I didn't draw it very accurately, but that's okay. I didn't do that on purpose, but it's actually good that that this looks a little bit longer than this because we just want to go by the information. We don't want to go just by what the picture looks like. All right? When you take your standardized test, you know what that is? Like your, the one where you fill in the bubbles and stuff like that. When you take the SAT, which you'll be taking next year, you'll be taking the PSAT next year during school at some time. Oh, you took it in 10th grade? Oh, okay. All right, yeah, so you do the practice one 10th grade, you take the real one 11th grade, right? So next year you'll be ready to take I think you can take it at any time, to tell you the truth. But most of the time, you'll wait till you're a junior to take it. But you'll see some geometry on there. And you might even see, they might have a picture like this, and underneath of it, it might say not drawn to scale. That means you can't just look at it and say, well, that looks like a right angle, or that side looks like it's bigger than that side. You can't do it. You can only go by the information that they give you. So I didn't purposely draw that not the same, but it's good for us to see. What else is equal? Well, this one right in the middle, okay? So what do you think? Oh, I'm sorry. I lied. I wanted to give the angles first. All right, so you do know. No, I'm sorry. No, we're good. I was right. All right, and they tell you an angle. Nico. Yeah, see, don't apologize. Just don't talk. I don't know why we discuss that every single day. All right, here we go. And here's your comparison. You're going to compare UV, put a blank right there, to VW. The length of, right? You're comparing the lengths of some sides. So where is UV? UV is right there, isn't it? And where is VW? It's this one right there. Everybody with me? Now look what we have. I got a side, angle, side. But I don't have the angles equal to each other, do I? If they were equal to each other, we knew we would have congruent triangles. So you know they're not congruent triangles. But you got two sides, right? Two sides of one triangle, two sides of another. But look at this. Angle 53 is what compared to angle 37? It's greater than. Everybody see that? So if the 53 is bigger, then the UV is what? Is bigger than the VW. Everybody see it? See? This is opposite. It's opposite the bigger angle, so it's the bigger side. This is 37. That's the smaller angle. And so this side right here should be smaller than this side right here. Or the way they wrote it, this is bigger than this. So UV is what? Greater than. That's all you do. Logan, you getting all this? Okay, doesn't seem like it. All right, that was example 4. Let's do another one. Now this one's, it takes it a step further. We're not just looking at it and saying, okay, which one's bigger than the other one. Okay, we're taking it just a little step further. And we're going to put some algebra in here. And we've done that before, right? We've done it all year, really. Put some algebra in there. But this is a little different because this is algebra with inequalities. Did you do that last year in Algebra 1? Instead of having like x is equal to 3, x is greater than 3, stuff like that. That's kind of what we're going to do here. Again, I'm just going to try to... I'm just eyeballing this. So these sides that they say they're equal may not actually be equal to each other in the picture, but that's okay. All right, let's see what we got. They tell you that this side and this side are equal to each other. Everybody see that? They also tell you this angle down here on the bottom. They tell you that's 100 degrees, and this angle on the other triangle up top is 70 degrees. And they also tell you that this side and this side are equal to each other. They tell you this is 3x minus 1, and they tell you this is 5 minus x. All right, so we're okay for the first step of this problem. The first step, we got to find out what side is bigger than the other side. Okay, so let's compare. I got a side, and I got an angle in between. Do I have the same thing over here? Yep, I got a side equal to a side over here. Got this side equal to this side. So I got a side and an angle in between. So what does that mean? That means this 3x minus 1 is what compared to the 5 minus x? This is opposite the 100. This is opposite the 70. So tell me something about the 3x minus 1. It's greater than 5 minus x. Okay? That's our first step, but we're not done. Okay, we got to do a couple things here. The first one's not too bad. The second one's kind of weird, so just watch. Does everybody understand that first part? That's basically what we were just doing, okay? But now it's a little different because they're asking you to find what x is. Not what it's equal to, because we don't know exactly what it's equal to, but we want to find the range of x. I'll talk about that in a second. So let's do some algebra. When you do algebra with less than or greater than, you do it exactly the same as if it was an equal sign, with one exception. Do you remember? Well, actually, two exceptions. But what's the exception? If you multiply or divide by a negative number. Anybody remember that? Okay, so watch. If I had 3x, if I had negative 3x is greater than 10. If I had something like that. Actually, let's make that 12. Okay? What if I had this? And I wanted to find what x is. Okay? What would we do? Pretend it was just an equal sign. What would we do? We get rid of the negative 3. How do we get rid of this negative 3 if this was an equal sign? Yeah, divide. Divide by negative 3. But remember what I just said. Listen to me. If I divide by a negative, or if I multiply or divide by a negative number, I have to change the sign of the inequality. Did you hear me? So am I dividing by a negative? Yeah, absolutely. If I divide by a negative or multiply by a negative, in this case we're dividing, you have to change the sign of the inequality. So what happens here? That cancels out. I got an x. I don't put greater than now, do I? What do I put? I put less than. And then what's this? It's negative 4. Everybody with me? If you divide or multiply by a negative, that's when you change the sign. Any other time, if I add, if I subtract, if I multiply by a positive, if I divide by a positive, I just keep the inequality exactly the same. I don't mess with it. The only time I change the inequality is if I multiply or divide by a negative number. Okay? So with that in mind, that's just a little rehash of Algebra 1. With that in mind, let's do this. So I got to get x's on the same side. I only got 5 minutes, so let's do this quick. I'm going to add an x here. I'm going to add an x here. Agreed? You know that cancels out. What's the next thing you're going to do? Come on, we've done this a lot this year. I'm not going to divide by anything just yet. I got to get rid of this minus 1. How do I get rid of a minus 1? I don't subtract. Not on a minus. I add. I always do the opposite. Okay? So if it's a negative, I add it. And then I got to add it over here. All right? So that cancels out. What am I left with? 4x, right? Because it's 3x plus 1x. It's greater than. Have I multiplied or divided by a negative yet? No. So do I change my inequality? No. Keep it the same. Bring everything down. What's that? Now I divide by 4. Now I'm dividing, but I'm dividing by what kind of a number? By a positive number. Do I change the inequality? No. All right, so x is greater than, reduce it, what's that? 3 over 2. Now you would think you would just circle it, correct? All right, now watch very carefully. I'm losing some of you guys already. I only got 5 minutes, so let's watch. This is really important. We're getting to the most important part, and this is where you're not paying attention. That's the worst part, to not pay attention. So here's one more thing we have to do, okay? I don't know the best way to explain this, but I'll say this. We'll do it like this. Do you see this right here? I should have thought about having a good explanation for this, but I don't. But watch what we're going to do. You're going to take this one right here, and what you're going to do, you know this can't be a negative number. Agreed? All right? So it must be what kind of a number? Because you can't have a negative length of a triangle, can you? I mean, you can't even have a 0, can you? So it has to be, it's got to be greater than what? No, not 1. It's got to be greater than 0. Now that's the weirdest part about this, okay? But just write it down, and maybe we'll remember that. So now, let's do this. Let's watch. Let's solve for x now. So first thing I'm going to do is subtract a 5 from both sides. Do I change the inequality if I subtract? No, not subtracting. It's only when I multiply or divide by a negative number. Now, look at this. I got negative x. It's like having a negative 1x. How do I get rid of that negative 1? I don't want a negative x. I divide by a negative 1. Now, what did I just do? I divided by a what? A negative. So what am I going to have to do with my inequality? I got to change the direction of the inequality. So, no, it's not y. All right, so it's going to be less than 5. Now, this is really important. Normally, we just get an answer. We just get one answer for x, okay? But remember, whoops, what am I doing? Hit that button. Look at this. I don't know. There's no way I can find exactly what x is equal to. But I can find a range of possibilities for the x. Nico, you're not paying attention at all. For the last 5 minutes, you haven't. Don't say you're sorry. Just pay attention. Okay, I only got 2 minutes left, so let's just watch. So I need to find a range of possibilities. So what does this mean? Let's think of a number line real quick. Do you remember in Algebra 1 you had number lines? Remember this? Okay. Remember you had, you could put a 0 in there if you wanted to. But this has a 5 in it, so I'll put a 5 here. What's 3 halves? That's 1 1/2, isn't it? So let me just stick a 0 in there. So 1, 2, 3, 4. Is that all right? Let's do this. So where is 3 halves? It's 1 1/2. It's right there, isn't it? Don't leave. Where is 5? It's right here, isn't it? Okay? Now watch. X must be bigger than 1 1/2, and it must also be what? Smaller than 5. Do you remember how to do this? You put an open circle here, an open circle here, and then you shade everything in between. Okay? One more step. I know this seems like a lot, but just watch. It's on video, so you can watch it later. So x is any number that's in the shaded region. So here's how we write it. X could be a number that's less than 5, and x could be a number that is greater than what? 3 1/2 or 3 halves. So 3 halves must be less than x. This right here is how they want you to write the answer. Okay, so you have your homework. We'll definitely talk about that more tomorrow. But let me give you your homework. You already got it on your lesson plans. Well, the nice thing is it's on video, so you can always go back and look at it again. So pages 238, 239, 13 to 16. What's that? It is interesting, yeah. So what's cool, maybe we'll do this tomorrow, Trent, but watch. You could pick any number in here. Pick a number between 1 1/2 and 5. Pick a nice easy number. 3, okay. So if you come up here, watch. A 3 will make this side bigger than this side. So if you put a 3 in for this, 3 times 3 is 9, minus 1 is 8. Put a 3 in for this. 5 minus, hold up. Yeah, put a 3 in for this. 5 minus 3 would be what? 2. Is 8 bigger than 2? Yeah, it'll always be that. Any number that you pick between 1 1/2 and 5, any number, it's always going to make this side bigger than this side. But once you go outside those barriers, like if you go less than 1 1/2, like a 0, let's put a 0 in there. Okay, 3 times 0 is 0, minus 1 is negative 1. You can't even have a length of a side to be negative 1. That's why x could never be less than 1 1/2. Try a number bigger than 5. Okay, 6. Let's try that. 3 times 6 is 18, minus 1 would be 17. But put a 6 in for this. 5 minus 6 is negative 1. So that won't work. So you could try any numbers to the left of 1 1/2, to the right of 5. None of those will work. Every single number between 1 1/2 and 5 will make this side bigger than this side. Okay? And that's what's kind of cool about that. All right. You guys can go.